Now let's understand what are different types of bond one by one. So as we have discussed, let's first talk about ionic bonding. What is ionic bonding? Now, in ionic bonding, electrons are completely transferred to the different atom. But that is not the case in the covalent bond. That we will look after. But let's first understand about ionic bonding. So when we talk about ionic bonds are formed by complete transfer of electrons between atoms of two elements. So there is a transfer of electron and there is no sharing of electrons. This is important, correct? Now let's move ahead. Now what happens when there is a transfer of electron, or there is, suppose let's talk about any atom, like suppose take Na, that is a sodium. So what will happen when sodium will lose electron? Obviously there will be charge on it, correct? And let's talk about chlorine. So what happens when chlorine will accept electron? There will be a chloride atom. So, and there will be formation of Na plus NCl minus. Correct? So, let's look further. So, ionic bonds are electrostatic force of attraction between the cation formed by the element which loses electron and the anion formed by the element which gains electron. Now, just now we have seen the example in the case of sodium chloride. When sodium loses one electron, what we get? Na plus. Similarly, when chlorine accepts one electron, what we get? A chloride ion. Correct? So, there is a force of attraction between Na plus and Cl minus. Obviously, there is a charge separation. Na has a plus charge, which is a cation. Cl has a minus charge, that is a anion. So, obviously, plus and minus will try to come together. So, they come together, and that electrostatic force of attraction is nothing but your ionic bonding. Now let's move ahead. Let's further understand. In ionic bond, there is a large difference in the electronegativity of the atom of the two elements involved in the bond formation. Why so? Obviously, we are talking about a cation and an anion. One is electropositive and one is electronegative. Just now we have seen the example of NaCl. If we talk about Na, it is from your S block, which is on your extreme left hand side. And if we talk about chlorine, which is from P block, which is on your extreme right hand side of periodic table. So your chlorine is electronegative in nature and your sodium is electropositive in nature. And if you compare the electronegativity of sodium and chlorine, obviously the electronegativity difference is very high because one is electropositive and one is electronegative. Now let's talk about some different example apart from sodium chloride. Let's discuss about sodium fluoride. Sodium fluoride is nothing but your NaF. So what is the electronic configuration of sodium? What is the atomic number of sodium? Atomic number of sodium is nothing but 11. Correct? So when we write electronic configuration of sodium, we will write 2, 8 and 1 that we have seen. Similarly, when we talk about NaF, we need to talk about fluorine also. So what is the atomic number of fluorine? It is nothing but 17. So the electronic configuration of fluorine can be written as 2, 8 and 7. Correct? Now, if we talk about valence electron, now student, what is valence electron? The valence electrons are the electrons which are situated in your valence shell. Now, what is valence shell? Valence shell is nothing but the outermost shell of your atom. Correct? So, remember one thing. Obviously, the bond formation will be taken place between the two outermost orbitals and the inner orbitals will not take part. Now that you have understood this, let's move ahead. In sodium, we have said that the valence electron is 1 and in fluorine, the valence electrons are 7. Now, for sodium, it is easier to donate 1 electron in order to achieve the octet or stable electronic configuration, and in case of chlorine, it is easier to accept 1 electron instead of donating 7 electrons. Correct? So sodium being electropositive, what happens? It donates 1 electron. As you can see on the screen, it donates 1 electron to fluorine. And fluorine being electronegative, that means what? It attracts the electron towards itself. So that will accept 1 electron. And what happens when you donate 1 electron? You get Na plus. And what happens when you accept 1 electron? You get F minus. So again you can see there is a formation of charges, and this formation of charges leads to the electrostatic force of attraction, that is nothing but your ionic bond. I hope the ionic bonding between sodium fluoride, that is your NaF, is clear to you. Now let's look at some different example. Now let's look at this example. This is nothing but your calcium chloride. Now NaF was 1:1 ratio element. Now let's talk about calcium chloride. So what is the electronic configuration, or let's say first, what is the atomic number of calcium? The calcium atomic number, as you know, is 20. The calcium atomic number, as you know, is 20. Correct? So when I talk about calcium, the atomic number is 20. So the what will be electronic configuration now? Electronic configuration will be 2, 8, 8 and 2. Correct? Now let's talk about chlorine. What is the electronic configuration of chlorine? That is nothing but 2, 8, 8, 7. Now there is a case where calcium has 2 valence electrons and chlorine has 7 valence electrons. So it is easier for calcium to donate 2 electrons, and it is easier to accept fluorine 1 electron. But if calcium donates 2 electrons, fluorine has the capacity to accept only 1 electron. Correct? So now in the case of calcium chloride, we need 2 anions, and hence the valency of calcium is 2 plus, and hence the bond formation we get CaCl2, because your chlorine can only accept 1 electron, and hence we require 2 chlorine. Now as the diagram suggests, calcium, the X is nothing but 2 electrons of calcium. Now calcium will donate 1 electron each to chlorine, and obviously there will be formation of Ca2 plus and 2Cl minus. Correct? Is there any doubt now? I hope this is very clear to you. So there is a charging. So there is charge formation of 2 plus and 2 minus, and again this is electrostatic force of attraction, nothing but 2 plus and 2 minus. So electrostatic force of attraction between calcium and chlorine leads to the bond formation, that is nothing but your ionic bond, and this is how you get CaCl2. Now let's move ahead.